Hi again, everyone. Dr. Tom McNamara back again for our course in Prep for College Math. This video is actually about dividing fractions, but before we do that, I wanted to review the concept of multiplying fractions. You need to build on this to work on dividing fractions. And the rule for multiplying fractions is multiply straight across. Fractions are very easy to multiply. As we'll see in a later section, it is adding and subtracting fractions that gets a little challenging. But if I wanted to do something like this, let's say 3/4 times 1/2, I multiply straight across. 3 times 1 is 3, that's my numerator. 4 times 2 is 8. That is my denominator, 3/8. And if you look at the video in the previous module, I recommend thinking of it like this. You're doing 3/4 of 1/2. Okay? Whenever you see this multiplication, I think of the word of. So to visualize 1/2, well, what we would do is we would take an object like this rectangle that I'm drawing right here, and we would cut that into 2 equal parts, and then we would take one of those 2 equal parts. So this is a representation of 1/2. Now I'm going to do 3/4 of this. So what I'm going to do is I'm going to cut my shaded portion into 4 equal pieces, and I'm going to shade 3 of those 4 equal pieces. And then we're going to look at what is double shaded. Okay, now when I do that second cutting of my figure, notice I have made 8 pieces. And if we look at the pieces that are double shaded, we see 3 double shaded pieces out of 8. In other words, 3/8, which we got up there. Okay? So, that's our review for dividing fractions. Sorry, that is our review for multiplying fractions. Now, when we're talking about dividing fractions, the rule is multiply by the reciprocal. And we'll talk about what that is. And in particular, it's the reciprocal of the divisor. Okay, so the rule for dividing fractions is multiply by the reciprocal. So I suppose before we get started, we should talk about what reciprocals are. Well, reciprocals multiply together to give you 1. They are multiplicative inverses. So I'll just do a couple of quick examples here. And we'll say find the reciprocals of each. Okay, let's start with 3/5. Okay, the reciprocal of 3/5 is 5/3. Okay, now remember I said reciprocals multiply together to give you 1. You don't have to do this every time I ask you to find a reciprocal, but I'm just doing this right now to check. Okay, 3/5 times 5/3 is 15 over 15 because we're following our rule for multiplying fractions by going straight across, and 15 divided by 15 is 1. Alternatively, you could cancel out the 5's and cancel out the 3's, remembering that when you cancel like that, you're left with a 1. Okay, so let's do a couple of other reciprocals here. Let's do the reciprocal of, I don't know, like 8. Okay. Well, remember, you might say, okay, well, we don't have a fraction there, Dr. Mack, but actually every whole number is a fraction. You can treat 8 as a fraction with a 1 in the denominator. Okay, so when we're seeing 8, we should think 8 over 1, and then the reciprocal is 1 over 8. So notice, to make the reciprocal, I am switching the numerator and denominator. Okay, so the reciprocal of 8 is 1 over 8. Let's do negative 5 over 6. The reciprocal of negative 5 over 6 is negative 6 over 5. Okay, notice I have once again switched the numerator and the denominator, but I have kept the negative sign. Okay, so a quick note here, a reciprocal has the same sign as the original number. Okay, and if we think, why would that be true? Well, remember what reciprocals are supposed to do. They are multiplicative inverses, so they are supposed to multiply together to give you 1. Positive 1. These two numbers have the same sign. When I multiply them, I will get a positive. Okay, so I'm going to get a positive 30 over 30, which is 1. Okay, if this thing didn't have a negative, I would have a negative times a positive, so the answer would be negative. I don't want a negative answer, so I have to keep that negative over there. Okay, so let's do a few quick examples of dividing fractions. So we'll go ahead and work on these. Let's take 2/3 divided by 7/8. Okay, so the way we're going to set this up, we're going to do 2/3 times the reciprocal of 7/8, which is 8/7. And now it's a multiplication problem. Multiply fractions straight across. 2 times 8 is 16. That becomes our numerator. 3 times 7 is 21. So this is 16 over 21. Doesn't look like this can be simplified. This numerator only has factors of 2, and this has a 3 and a 7 for its factors. Okay, let's look at another one here. Let's take 4/5 divided by 8 over 25. So same procedure. We are going to multiply by the reciprocal of the divisor. Now remember, if you think back to our work on division, this is the dividend, this is the divisor. The divisor is the thing you're dividing by. 4/5 divided by 8 over 25. This is the divisor. So we take the reciprocal of the divisor. Notice this stays 4/5. And up here, you notice the 2/3 stays 2/3. It was the 7/8, the divisor, that we took the reciprocal of. Okay, so 4/5 times 8 over 25. Erase that there. Okay, so I would recommend doing some canceling on this one. Okay, we know 25 goes into 5, and the other factor is a 5. The 8 and the 4 have some common factors. The remaining factor is 2. So that is 5 over 2. Okay, improper fraction, but that's fine. Don't worry about it. A couple of other ones. Let's take a whole number here. Let's take 80 divided by 20 over 11. Okay, so I am going to write my 80 as a fraction, remembering that every whole number can be written as a fraction with a 1 in the bottom. And then I'll take the reciprocal of my divisor, 11 over 20. And now I'll do the multiplication. But remember, much easier to cancel before you multiply. If you look back to the assignment on multiplying fractions, that was a point of emphasis. Much easier to cancel before you multiply. And when you're showing work, this is what I'm expecting to see. Okay, if I ask you to show work on a problem, this is the type of thing I'm looking for. Okay, and once again here we're multiplying straight across. 4 times 11 is 44. 1 times 1. Remember, if you cancel out the whole denominator, that's leaving a 1. It's not leaving a 0, it's leaving a 1. So we got a 1 down there, okay, and that's just 44. Okay, so 80 divided by 20 over 11 is 44. Okay, I think one more is probably enough. Actually, okay, we'll do 2 more. Okay. So I'm going to do 2/3 divided by -7 over 6. Okay, so I know my answer is going to be negative. I left myself a little space to do my work. I know my answer is going to be negative. You might say, all right, Dr. Mack, how do you know that? Well, this number, this fraction, is positive. This fraction is negative. I am dividing things that have different signs. And remember, the sign rules for dividing are the same as the sign rules for multiplying. If you multiply numbers that have different signs, your result is negative. So if you divide numbers that have different signs, your result is negative. So I'm going to do 2/3 times negative 7/6. Oop, no. Forgot to take the reciprocal. That was sort of the whole point of doing this. Okay, and now I can do some canceling here. So I get -4 over 7. Remember, once again, we're multiplying straight across. The 6 and the 3 have a common factor, namely a factor of 3. So the factors of 3's can be canceled. You are left with a factor of 2, because the 6 had a 2 and a 3. So the 3 cancels, the 2 stays. Times this other 2 over here gives me the 4. 1 times 7 gives me 7. Okay, so once again, remember, this class builds. Okay, when we did the work in Chapter 2, we did work with signed numbers, multiplying and dividing signed numbers. Those rules still apply here. Okay, one last problem. I want to look at a word problem here. Okay, I'm just going to kind of sneak the book under the camera so I can get the statement of the problem right here. Okay, so let's look at this one right here. Yoink, over here, this self-check. Okay, a recipe calls for 4 cups of sugar, and the only measuring container you have holds 1/3 of a cup. So you need 4 cups of sugar, and your measuring container is, you have a 1/3 of a cup measuring container. How many of those do you need to use to get the recipe? Okay, so let's go ahead and answer this problem. Readjust my Mechanical zoom there. Okay. So what we have is a 1/3 of a cup measuring cup. And we need 4 cups. All right, well, if we just think about this here, 3 of the 1/3 cup will give 1 cup. Now we need 4 of these cups. So we need 4 sets of 3. Okay, so we need to use this 1/3 cup thing 12 times to get the 4 cups. But if we think about it, there was a much faster way to get that, which is 4 divided by 1/3. Right? We're breaking this up into groups of 1/3. How many groups of 1/3 make up 4? If we follow our rule here, we multiply by the reciprocal of 1/3, 12 over 1, 12. Okay? So fractions give us a much faster way of doing this. All right? So remember, dividing by fractions is built on our knowledge of multiplying by fractions. And of course, multiplying fractions is built on our knowledge of multiplying whole numbers. Okay, so everything builds on what we've done before.